Hello viewers. Today I'll be discussing how we can identify slow running queries in SQL Server and the basics of identifying the root cause or what is the resource on which the queries are waiting, and how we can monitor the basics of slowness and blocking, and generally the overview of if anybody identifies that this query is slow, so how we can identify the root cause for that. So the common scenario is that the application team reports that the queries or the applications are running slow, and as a database administrator we have to identify that what is the root cause for that. So for this we will be using different scenarios, and I'll be discussing that, and I'll try to reproduce some of the common scenarios and we will go through that. So for example, the most common one, which is the obvious one, is that, for example, if we have a table and somebody is locking a resource and other are waiting. So for example, if we have one table and there are some rows inserted, and somebody started a transaction in the application, and somehow it can be generally time consuming, or it was waiting for some resource but it didn't complete. So for example, if somebody started this query with a begin transaction, and for example we start a query for the select. So in this situation, the first user, it has started the update statement and forgot about the commit transaction, or sometimes actually this transaction was waiting for something, but there are other queries which depend on this resource will start to wait. So the first and most important thing in SQL Server is that we have to use the activity monitor, the SQL Server activity monitor. We right click on the instance and go to activity monitor. So this gives us an overview of the database server current situation. It is the real-time graph. On the left hand side we have the processor overview. Second is the number of tasks which are waiting. Then the database input and output, like how much throughput we have in terms of MB per second, and the batch request per second, like how many batches of the queries are running per second. Then we have the current processes which are active, or you can say in different state, but there are sessions. So it can be, let me just slow it down to 1 minute, and then it can be running, suspended, and blocked, all those stuff. So for example, right now the current situation is that we have started an update statement and other queries are waiting. So in the activity monitor you will see that this session, the 79 SPID, this is waiting for another session which is 51. If you see, this SPID is 51 and this is 79. So in 51, this SPID is locking this table, and this query is waiting. So we will clearly see that this wait time is increasing, and overall if you see this one is waiting for another session which is blocked by 51. So either you have to kill 51 or ask the person or the application to resume the locks. In some scenarios the queries generally are taking time, so in that particular scenario we have to optimize the queries. So this is the most important and common way how we can identify the processes which are waiting. So this processes part is one of the most common and important area we should be monitoring and looking forward to. Second is the resource wait. These are the general resources for the SQL Server on which the queries can be waiting. So for example, if we see the top wait right now is 1000 millisecond, and this is the overall wait on the server. Although the queries, if you see the query is waiting for so many minutes, but overall general wait time is this. And this is also an indicator that overall what is the health of your system. Like for example, if there is a network delay, if there is something regarding memory, buffer, latches, backup, anything. So this resource wait dashboard gives you a comprehensive overview of the resources like which are taking time, and the SQL queries or the application is waiting on that. Next is the database file IO. This chart gives populates every 10 seconds, and this gives us the response time in terms of millisecond for each file. So ideally, in an ideal system, the MDF, LDF, all the response time should be less than 5 milliseconds, which is like very good. And if we have a response time between 5 to 20 milliseconds, this is like normal, but not very good. And if we have something above than 20 milliseconds, it means the system is struggling, and you have to check with the storage system, the platform team, or like you have to verify like why it is giving us huge response time. So this response time should be less than 5 milliseconds. This is my machine, and because there is zero load, that's why the response time is 0. Then the next is the recent expensive queries. So these are the queries which were executed recently and took some time. So these are some of the top resource consuming queries, and you can sort them by different factors, like for example, number of executions per minute, the average duration, CPU millisecond per second. So these are different factors you can check. Like for example, if you see contention on CPU, or you see generally like the average consumption, average duration is high, so you can sort it by the average duration, and then further you can identify the queries and accordingly optimize those queries. Then this active expensive queries tab will give you the queries which are currently running, and they are resource consuming as well. So these queries you can easily identify because they are currently running, and you can, for example, right click, show execution plan, and you can see what's going on. So things like that. For example, currently the query which we are executing is having index scan, clustered index scan. Estimated number of rows is 9 million something, and estimated actual number of rows, most probably I think it is 1. So this is like a huge difference. I'll discuss this in detail shortly. So this is the first and most important overview of the activity monitor. And let's see if we do the commit. So the other query will complete, and there will be no problem. And for example, if we want to use another way, this was one way to identify the execution slow running queries. The other way is a very famous stored procedure SP who is active by Adam Machanic. So one of my favorites. So just do explore this one. So you can easily download it from his website. I believe SP Who is Active is the website. I will mention it in the description below, and on the download page you can go there. The latest one is now on GitHub. You can go there and download it, like SP Who is Active, and there you go, you can download it and you can use it accordingly. So download the whole package, and you can obviously review all the documentation on his website. So SP Who is Active, this is the code, and you can use it, and with this you can easily identify what is running, like who is active on your system. With this you can download the whole zip and deploy the stored procedure. So once you deploy it, you just have to execute it. That's all. Just copy paste it and you will execute. That's all. And once you execute it, it will give you the top SQL queries. So for example, you can see that this query 79, this one is waiting, and it is waiting for 51. This is the CPU, this is suspended, and it's doing nothing. So with this you also get an idea that who is being blocked and who is blocking. So it will give you a good information about your current system, which query is blocking, which query is top resource consuming. So with this also, as a tabular format, it gives you very good information about the resource consuming queries which are actively running. So this one I strongly recommend to download and use. This is free to use. Okay, so we'll just commit it and we will go to our next part. So for example, right now, if we start to insert millions of rows, so in the same table. So for example, let's start with this one and make it like something 10 million rows, and see what is the resource we get. So for example, if you see here, as of now, you see that there is no wait, although our queries are running and they are working fine, because it's just the query, it's taking time because it's huge, like 10 or 20 million rows I'm inserting in one table. So this query is taking time, but actually it's not waiting for anything. Similarly, if you see SP Who is Active, you will see that this is a resource consuming query, and it is reading and writing. It is taking a CPU. So for example, if we constantly refresh it, but it's not blocked by anything. So this is one of the active queries which is reading and writing, but it is not being blocked. So this is this gives you a very detailed view of the queries which are running. So see, if you want to get the query, it will give you the query itself as well. Okay, so with this one, if we go to the state of the tasks with non-blanks and constantly refresh it. So now you see that previously it was like 1 MB per second, but now the database IO is increased. A little bit of CPU is being used. We have a comparatively higher number of batch requests per second. So this system is slightly more busier than before, because now we are inserting something and it is being used. So with this, you can also see like different resources. Like for example, now you see the logging is on the top as well, and there are other resources. So with this one, you can see that in this graph, in this activity monitor, you can clearly see the as is and to be situation, that whenever we have high resources, so as compared to the time when the system was not busy, you can easily see the difference. So that's why the resources and for example the processes database IO. All these are like very important for our system. And if we see if there is any process, no, we do not see any lag so far, which is good thing. And the recent expensive queries, if we see like which one is the expensive query, so see the number of executions per second, executions per minute, logical reads per second, these are on the top. So it clearly says that this query was taking most of the time. So this gives us another way of verifying that we can see which query is most expensive and how we can use it. The next part is that we have to enable the query store. This one, the query store, by default it is off. So once we enable it, so it will start to collect the data, and we will give it some time. So it will collect some data, and then we will see how we can utilize this query store to see the top resource consuming queries. Meanwhile, for example, if we have a query, for example this query, and we want to see if this query is slow or if this query can be optimized, so we have to see in terms of the time and IO both. So once we execute this set statistics time comma IO on, so all the details for this query after being executed, we will get information about the CPU and the IO the query used. So this is the result, but on the messages tabs, if we go and see that once we execute this set statistics IO on, and we with the reference of Microsoft learn.microsoft.com, so the logical reads are the number of pages read from the data cache, and the physical reads are the number of pages read from the disk. So for example, the table is already cached in the memory, so anything which is already in the cache, so once SQL Server will be reading from that, it will give us the number of pages as a count, but it will be logical reads. So if something is not in the memory and the SQL Server has to bring the pages from the disk, then it has to go to physical reads. So that will be the number of pages read from the disk. So now we can see that this table with this query, it read like 58,000 logical reads, which is a huge number for a very small query. And once we see that, we go to execution plan, and we clearly see that there is a clustered index scan going on. And I would strongly recommend to use a third-party tool like SQL Sentry Plan Explorer, which is free of cost. And this information is good for like general use, but once you want to get details, it's better to use Sentry Plan Explorer. So you have to install it. So Sentry Plan Explorer is again a free tool. So if you go to its website, SQL Sentry Plan Explorer, yes, it's already there, and this is a free tool. So it will give you a detailed analysis on the queries, whatever you want to use, and the execution plan, especially like if you want to zoom in, zoom out, a very big execution plan, it will give you details about that. So let's go back to our query, and because I have already downloaded it and installed it, and this will be integrated in the Management Studio. So this is very handy. So I always install it on the client machines. So whenever there is a query which is slow, so we can use this tool and see the details. So once we want to use view with SQL Sentry Plan Explorer, we will click on View SQL Sentry Plan Explorer. This whole execution plan will be imported in the Sentry Plan Explorer. So now you see that the reads are 58,000 reads, and estimated IO cost is like 100% is this operation. Estimated row is 1 and actual row is 1. And if we want to see that, okay, the details are the actual number of rows read is 11 million. Wow, this is huge. And estimated number of rows are 1. So this seems like a very bad execution plan, and it suggests the index creation as well. So for example, if we create the index on this table, and let's create the index that on the same table, let's we will create the index on name, the column name, and included column is ID. So let's see. So it took a couple of seconds, and after that, let's go back, and now you see that currently, as of now, without index, this table was reading 58,000 logical reads. Means it read 58,000 pages. So if we execute the same thing, same query again, and overall the CPU time was 500 millisecond. So the same query, if we execute it after creating the index, so we can see that the logical reads are now only 4, and it took 0 seconds, 0 milliseconds to fetch the table, fetch the data from the table. And now there is no warnings. We have actual number of rows read is 1, estimated number of rows is also 1. So this looks like a perfect execution plan. And if we see the same in SQL Sentry Plan Explorer, now you see the number of pages read is only 4. So instead of like how many pages? Instead of 58,000 pages, now we are reading only 4 pages. The same query, the same table, nothing changed except the index. So with Sentry 1, we can easily identify so many bottlenecks, and the details about the execution plan, we can easily get that. So it's a great tool to use. So always go for this. Now we will go to the database, and we will see if we have something in the query store. So now the query after enabling the query store, the most important is to check for overall top resource consuming queries. We refresh the query store, and we right click and view top resource consuming queries. So with this, we have different matrices for to check the queries on, like number of execution, duration. So for example, if you want to see the average duration of all the queries, so and if you click on this, it will give you the idea that which query is taking most of the time on an average. So this was the query on an average. It created the creation of the index. And if you want to see the number of execution on an average, number of total execution, so you will see the insert which we are executing, like millions of rows. So this is the query which is taking actually most of the time, which obviously makes sense. So in this way, natively SQL Server provides us a way, which is the query store, to check which queries are most top resource consuming queries. So for example, if you want to see the queries which are taking more logical reads, and for example, if you want to see the queries which are consuming on an average consuming more logical reads, similarly if you want to see the queries which are taking on an average more memory. So all these kind of different metrics you can use, and you can see the plans and executions of the queries and identify the most resource consuming query. So this is again one of the most important free tool which comes with SQL Server, and still SQL Server 2019 this is not enabled by default, but in SQL Server 2022 this is enabled by default on all the databases. So I strongly recommend to enable it for all the databases. So in case you want to go back in time and see what happened at what time, so you can easily see. For that you have to click on configure on the right top corner. Okay, this is getting slow. Let me stop the execution of the queries. Yes, let's stop it first. Okay, so then you can click on configure, and based on your custom time, like for example last 12 hours, last 2 days, whatever, or a specific time frame, that okay, on that particular day from, for example, 10 a.m. till on that particular day 10:30 a.m. what happened. So you can see based on those specific time frames, you can see the data. Because this I enabled it just now, that's why there is no data available, but otherwise you can see and go back in time and see what happened at that time. So this is like a very useful tool. And let's start the insertion again and see if we have any resource weights, because it should create some weights. Let's see if we have the weights already. Okay, yeah, see, now even we have network delay as well. So because this is on a virtual machine, so that's why it is causing a network delay, which is good for us to see. Like for example, in case if you have a delay in your network, this will also be clearly seen on the resource weight, and you can see, for example, async network IO. This will be the weight you will be seeing in the weight type, and overall the resource will be network will be high. So 1000 millisecond per second, this wait time is huge, so it should be less than 1 millisecond in an ideal scenario. So this is like very poor network performance. So this is also an indicator of why your queries are slow. So for example, if you have slow queries and you see the network IO is huge, so in that case, most probably even if you try to optimize the queries, or if you try to increase the resources, it won't matter, because the underlying infrastructure, one of the underlying infrastructures resources is slow. So this is just a summary of how you can monitor all your systems. And the SQL Server provides native tools to monitor the system and log the system. And there are some very good tools like SQL Sentry Plan Explorer. This is free of cost, and you can download and integrate it with Management Studio, and also Query Store. Obviously, the most important one was SP_who is active by Adam Machanic. So all these tools and third-party tools and community scripts we can use, and we can benefit from it, and we can monitor our systems and make sure the health of the system is up to the mark. So thank you so much. Please leave your question and comments below, and I'll try to answer them. Thank you so much.